So we've already discussed that about similar figures and we know how they work. Now, similar figures don't always have to be just shapes. For example, we can use it in the real world. So it says solve for the height of the flagpole. So we don't know the height of this flagpole right here, but we do know that it casts a shadow that is 6 feet long. We do know the height of this flagpole, and we know that it casts a shadow that is 2 feet long. So if you look, based off of the sun's angle, we know that these two figures can be considered similar. So we're just going to do exactly what we have been doing, where I'm going to set up squigglies and dashes. And if you don't want to necessarily do squigglies and dashes, you can always write the word equivalent. So I'm going to do my tic-tac-toe method so that I can stay organized. And I'm going to say, look, we're going to go from the big flagpole to the small flagpole, and we're going to put squigglies on top of dashes. Now the squigglies is representing the height, so I can write height right here, and the dashes is representing the shadow. So I'm going to write those right next to it. So when I look here now, looking at the big flagpole, the height is h. We don't know it. Looking at the big flagpole, the shadow represents 6. The small flagpole, the height is 7 and the shadow is 2. So from here what we are going to do is cross multiply and divide. I'm going to do 6 times 7, which is 42, and 42 divided by 2 will give me 21. So the height of this flagpole is 21 feet. Now another way you could have solved this is using scale factor. If you look, we're trying to go this direction. So if I look, to get from 2 to 6, I multiplied by 3, and we know the scale factor always has to be the same. So if I multiply 7 by 3, I would get 21, which is the height. So this next one, it says a fire tower casts a shadow that is 30 feet long. So what I'm going to do is I'm going to draw a shadow for this fire tower, and I'm going to write 30 feet. Then it says a nearby tree casts a shadow that is 8 feet long, so I'm going to draw an 8-foot shadow for my tree. And it says, how tall is the fire tower if the tree is 20 feet? So if you want to draw the similar triangles, you can. And we know that the height of this is 20. And it's saying, what is the height of this fire tower? And if you don't know what the height of the fire tower is, we're going to label it with X. So we have all of our missing measurements plugged in. Now we are going to set up our proportion using the tic-tac-toe method. On here, I am going from the fire tower to the tree. And if we want to, we can set up squigglies and dashes. That may help. So squigglies for the X and squigglies for the 20. And we could give dashes to the 30 and dashes to the 8. So when we look at this, we can say squigglies over dashes. And we know that squigglies is actually talking about the height. And we know that the dashes is actually representing the shadow. So when we look at the height of the fire tower is X, because we don't know, or it could be any variable you want. Looking at the fire tower, the shadow is equivalent to 30. Looking at the tree, the height is 20, and the shadow is 8. So from here, what we're going to do is we are going to cross multiply and divide. So if I do this off to the side, 30 times 20, well, 3 times 2 is 6, and then add the 2 zeros on, so we get 600. What we're going to do is 600 divided by the 8. So off to the side down here, I'm going to do 600 divided by 8. And 8 goes into 60 7 times, and we're going to subtract the 56, get a remainder of 4. Bring down the 0, and 8 goes into 45 times. So the height of my fire tower is 75 feet tall. This next one says a picture that is 10 inches tall and 14 inches wide is to be scaled to 1.5 inches tall to be displayed on a web page. How wide would the picture be on the web page for the two pictures to be similar? So I know that this is 10 inches tall, and I know that this is 14 inches tall. And when I look over here, it tells me that they're 1.5 inches tall, and I'm looking for X, the width. So from here, I'm going to set up my proportion using my tic-tac-toe method, and I am going to be going from the big picture frame to the small picture frame, and if we want to, we can give squigglies and dashes. If not, you can label it with the actual, what it's talking about. So squigglies is representing the height, and the dashes are representing the width, or how tall. And so when I look at this now, I'm going to fill it in. Looking at the big one, the height of it, or how tall the people are, is 10 inches. The width is 14 inches. Looking at the small one, the height is 1.5, and the width is x. So when I do this now, I'm just going to cross multiply and divide. So I'm going to do 14 times 1.5. When I do this, I get 5 times 4 is 20. 5 times 1 is 5, plus 2 gives me 7. 0 for place value, that's going to be 4 and 1. When I add it all up, I'm going to get 210, but I can't forget to move my decimal over one time. So what I have now is 21, but I can't forget to divide it by 10. Now, 21 divided by 10. Whenever we divide by 100, we move the decimal over one time. So because there's only one zero, we're going to move our decimal over one time. So over here, we're going to get x is equivalent to 2.1 inches. And the final one. So it says a toy replica of a tree is 6 inches tall. What is the length of the tree branch if a 8-foot tall tree has a branch that is 72 inches long? So when we look at this, we have to think about it in terms of, like, we can draw a picture. The one thing I am going to say is we're talking about how tall this tree is, and they need to be talking about the same units. Now I know this is completely different units, but that means our answer is going to be in inches. But when I look at this, we have to have them be the same. So if you think about it, a ruler has 12 inches on it, and that is equivalent to 1 foot. So 6 inches is half of 12, meaning that this is half of a foot. So 0.5 feet. So now let's try to draw a picture. We're going to draw a small little tree for my toy tree, and the branch is going to be kind of funky looking just because you have to make sure you can see the branch. And then we're going to draw our big humongous tree with its little branch. And now we're going to fill in what we know. This height of the toy replica we found was 0.5 feet. And we don't know what the length of the branch is. We're going to label this x. We know the height of this tree is 8 feet, and we know the branch is 72 inches. So the height and the height are both talking about feet, so the branch is in inches, so our answer needs to be in inches as well. So now we're going to set up our proportion using my our tic-tac-toe method. We're going to be going from the small figure to the big figure, and if you want to do squigglies and dashes you can, or if you want to write height. Sometimes I think it's easier to do this instead of drawing all of it, especially on our beautiful picture. And this would be our branch. So looking at this now, the height of the small one we know is 0.5, and we don't know the branch length, so we're going to put x. The big one, the height is 8 feet, and the branch is 72 inches. So from here, what we're going to do is we're going to cross multiply and divide. So we're going to do 72 times 0.5. 5 times 2 gives me 10. 5 times 7 gives me 35, plus 1 gives me 36, and I need to move the decimal over one time. So I get 36. Now I'm going to do that 36 divided by the 8 that we had. 8 goes into 36 4 times. We're going to subtract the 32. Get a remainder of 4, snake bite. And 8 goes into 45 times. So the length of this branch is equivalent to 4.5, and we talked, it needs to be in inches. 4.5 inches. Okay, and that is it.